Hi class, are you ready for one of the more complicated concept in the class? I guess it's getting more complicated anyways. So this is called linked list. So what is a linked list? It's a list construct using pointers, a kind of a data structure. We will actually talk about what data structure means, but I think showing you a graphic representation of what linked list is may help you better than explaining it in words. So it's basically a list of nodes that's linked by pointers. So this is the head pointer. It's linked to a node. A node is constructed by a piece of data and a pointer to the next node. And you will see that the nodes are connected with a pointer that's called next in our example. And then at the end, when there is no more nodes, the next will be point to NodePointer. The structure, or we are using struct for node at this point. This can be any data, but in this case, we would use just an integer to show this example to make it easier to understand. And we name the data just data. And then we have node pointer that is called next. Remember, when we have a struct, we always have this is semicolon at the end. We then declare a pointer type that is called NodePointer using type define. So basically, we are saying that, hey, define this type that is a pointer of a node start. It means the pointer of a node, and call it NodePointer. You will see, so basically this is a side note because I think we might barely have touched on this type def. Actually, I don't think we did. I purposely wait until this point to introduce you this idea because I think just in time delivery is best for learning. So because this is what you need to learn, this is what you need to know at this point. Type def in, I can actually define an integer type into another name called month, and then I would then declare month January equals to 1, for example. That's one way to declare a new type. The benefit of it is that you can later on in the code somewhere, you can also say, okay, month equals to March, if you don't want to declare everything at the same time. Compare that to enumeration. You can do it this way, but there are some differences. So in this particular situation, we would be using type def to define a node pointer because it doesn't make sense for us to go back to this and then change things here because we want to be able to declare a node pointer any point in our code. Now the head pointer. As you can see, a head pointer will point to the first node. After we defined the node pointer, sorry, I keep switching node and node. Node pointer head is the first one that we would declare because that's the first one that we definitely need for a linked list. Without that, we wouldn't have a linked list because there's not even the first one that basically, if without the head pointer, you can't access to the linked list. So don't lose it. In your code, you would even though we don't set it to a constant, because we can't. Sometimes the head pointer will change value, but without a head pointer, you basically lost the access to the linked list. How do you create the first node? So that's what we are going to do next. We would say head equals to new node. That's how we allocate a new piece or a new variable that is of type node, just like what we did earlier in the pointer review lecture, that we talked about how to create a double, basically a unnamed double variable. So right now this is an unnamed node variable. Then we can populate the data. So there's two ways to populate the data, because to access where head is pointing to and the piece of the struct member variable data, you can dereference by using the start head, or you can actually use something. It's like an arrow, so it's a dash and then arrow to the right. Both ways are exactly the same. So this way you've seen it before, and you need a parentheses because of the hierarchy of the which operator will be evaluated first. Actually, this has a higher priority, and that's why without the parenthesis this will not work. I personally like to use this way because I would think about the head pointing to the node where the node has the member variable data. So throughout all these videos that's coming up, we are going to use just the arrow operator. I think there's a name for it. Anyways, so we say head arrow data equals to 10, and that's how we assign the value to this first node. This is basically kind of repeating what I just said, so maybe we I think this is the statement that I want you to notice. Star head.data wouldn't work without the parentheses. So this arrow operator, we can use it to, it's basically like the referencing that we talked about in the pointer review. We can use it to access the current value. We can also use it to assign a new value to it. Then we haven't finished yet, right? Because we still have the next, which is a pointer to a node that we have not assigned to any value yet. We don't want to have it hanging like a dangling pointer. We always want to put NodePointer at the end. It's very important to have it because we know that this linked list ended. Without that, there might be random data out there. This is pointing to, or not a valid address even, and then something bad can happen. So always remember to set the last node, the next node pointer always has to be set to a node pointer. So I call it the tail. You can actually use null. That's traditionally what people do. And so I'm sure if you eventually find a job as a programmer, if you program C++, you might still see code that people would use null. NodePointer is introduced in C++ 11, which means about 8 years ago. So what's the difference of the two? The NULL capital is the older way of setting a null pointer. Basically, it can be assigned to any type. It doesn't have to be a pointer type, and it actually has a value of 0. But null pointer is newly introduced in C++ 11, which can only be assigned to a pointer, and it doesn't actually equal to 0. So throughout this class, we are going to just use the new one, NodePointer. So let's look at how it looks like in code. So basically, we talk about the whole thing through, but we didn't look at it all together. So I'm going to start typing, and this is the struct that we are going to use, and it's an integer. We call the member variable name is data, and then a node pointer which has the name next, and then we would do a type define and define this the pointer to a node to call node pointer or anything you like. And then so how to create the first node? So first of all, we need the head pointer, call it head. So we don't need the start anymore because this is already a pointer. And then we will create a new node, and then we will set the first node's data to 10. So how do we do it? We say head is pointing to, so we want, right now head is pointing to a new a node already, and so we just want to assign 10 to head arrow data equals to 10, and then set the node that maybe I want to show you the graph, maybe it's easier to understand. So what we just did is that we set the head point, the node that the head is pointing to, head arrow data equals to 10, and then next one we are going to set head arrow next equals to now pointer. So that's what we are doing. Then I would output head is pointing to the value. So we are accessing the data and see what it is. And then at the end, we need to remember to clean up though. So always clean up, always. It's a good habit. Right now you're writing short programs, so it might not matter, but when you are writing big program, if you have memory leaks, it's not pretty. It can be really unsightful, some words like that. So let's compile this program. Apparently I forgot what I told you, that is important to have the semicolon. And so because I didn't have so this will be prettier. So head is pointing to 10. You can download this code to play with as usual in your module. So this is the code repeat. I thought it might be helpful to you when you study, because honestly this is one of the hardest chapters. So something to think about. You realize that I do delete once because there was only one new keyword that I used to create a new record, and so always match the number of delete to the number of new, basically. Second is that you cannot actually do this first. The type define node pointer cannot precede the struct node, because before node it's defined the struct. You can't actually do this step, and that's why you can't actually put this node pointer inside the node before this is completely declared. Just something to think about. So to recap what we talked about, we talked about what is a linked list, what is a node struct, how to set up linked list with one node. We talked about the head pointer. We talked about the last node will always point to a node pointer. We talk about how to use arrow operator to access member variables of a struct from a pointer. We talk about how to dereference a pointer. We also talk about how to define a new type using type def. So we would try to see how to write a function to insert nodes at the head of a linked list next. See you soon.